During separation, solids collect at the wall of the bowl, and we need to periodically discharge a metered amount. Discharge can only be made by reducing the closing pressure of the operating water under the sliding bowl bottom. This is done by allowing some of this water to escape through these drain holes. They are closed off by the plugs attached to the operating slide, which is being forced up by the coil springs, or hydraulically in some systems. The valve in the opening line is opened, injecting water into the space above the operating slide, called the opening chamber. The water is thrown by centrifugal force to the periphery of this space. This nozzle allows some of the water to continually escape, but since the quantity of water being supplied is greater than the amount of water escaping through the nozzle, the water forms a level and starts to fill inwards. The great pressure produced by centrifugal force on the water means that only a small level of water will produce sufficient force to overcome the comparatively weak coil springs. The drain holes open slightly, allowing the operating water under the sliding bowl bottom to escape into the chamber. This extra water flowing into this chamber causes the level to fill in at a faster rate. And although the control system has closed the valve in the opening line, the water which previously held the sliding bowl bottom up now helps to press the operating slide down, reinforcing the downward opening force on the operating slide. Water is now draining out from under the sliding bowl bottom. The level moves outwards, reducing the upward closing force on the sliding bowl bottom. When this force drops below that of the downward opening force, the sliding bowl bottom drops, uncovering the discharge ports. Meanwhile, the operating water escaping into the opening chamber continues to fill inwards and rapidly overflows into this chamber called the closing chamber. The closing chamber also has a small draining nozzle. This chamber quickly fills inwards, creating an upward closing force on the operating slide. At the point where the combined forces of the water under the slide and the coil springs exceeds the opening downward force of the water above it, the slide will be forced up, sealing the drain holes of the space under the sliding bowl bottom. The opening chamber and the closing chamber continue to drain. Both have the same size drain nozzles and will drain at the same rate, maintaining the closing force on the operating slide. Now the drain holes in the space under the sliding bowl bottom are closed, the level of the water moves inwards, supplied from the static header tank, situated at around 3 to 4 meters above the bowl. This increases the closing force on the sliding bowl bottom until it becomes sufficient to overcome the opening force of the processed liquid above. The sliding bowl bottom moves up, closing off the discharge ports. The level continues to fill inwards until it touches the pairing disc in the pairing disc chamber. The action of the disc on the rotating water re-establishes the equilibrium in the operating system, and the bowl remains closed until the next shock. Let us look at the complete cycle once more. The contents of the bowl are undergoing separation. Unclarified liquid is entering here. The heavy phase is separated from the light phase. The heavy phase is pumped away here, and the light phase here. Solids build up at the bowl periphery. When it is time to discharge the solids, the interface between the liquid phases is repositioned by closing the water outlet valve and opening the water supply valve. The interface moves in. The valve in the opening line is opened and the opening chamber fills in. The downward force on the operating slide overcomes the coil springs and the slide drops, uncovering the drain holes for the space under the sliding bowl bottom. The operating water under the sliding bowl bottom rapidly fills the opening space. The valve in the opening line closes. Meanwhile, the level in the space under the sliding bowl bottom has moved outwards. And the reducing closing force allows the sliding bowl bottom to drop, uncovering the discharge ports. The water in the opening chamber overflows into the closing chamber and fills in. The upward closing force it exerts on the operating slide, plus the force of the coil springs, seal the drain holes for the space under the sliding bowl bottom. Whilst the opening chamber and the closing chamber continue to drain at identical rates, the level in the space under the sliding bowl bottom is replenished by the static head supply. The level moves inwards until the resultant increase in the closing force forces the sliding bowl bottom up against its seal, closing off the discharge ports. The level in the pairing disc chamber fills in until the pairing disc and the static head re-establishes equilibrium. The solid's discharge period is determined by the time taken for the operating water leaving the space under the sliding bowl bottom to overflow and fill the closing chamber sufficiently to force the operating slide up, closing these drain holes. This time, in turn, is determined exactly by the volume the water has to fill, namely the closing chamber. On certain models, the volume of the closing chamber may be adjusted by selecting suitably sized filler rings. So that for each chamber volume, an exact solids discharge period is achieved for each and every shot. We have seen that a total discharge is effected by a series of partial discharges. Here we see the rotating bowl has been prepared for emptying. The light phase has been displaced by the water and the feed turned off. The first of a series of discharges is initiated, and this results in a fixed amount of water escaping from under the sliding bowl bottom, and the level moves out to this point, allowing the sliding bowl bottom to drop. The level of the liquid in the bowl will move outwards, reducing the downward opening force on the sliding bowl bottom. When this force becomes less than the upward closing force of the operating water, the sliding bowl bottom will move up, closing off the discharge ports. The operating water must be prevented from returning to its equilibrium level in the pairing disc chamber, since the next discharge cycle will simply cause the level of the operating water to return to this same point. If we shut off the valve in the closing line, the operating water will not be topped up, and the next discharge period will cause this level of operating water to move further out along the space. The sliding bowl bottom will now drop. And the level in the bowl moves out until the reducing opening force it exerts on the sliding bowl bottom again drops below the upward force of the operating water. This cycle is repeated until the bowl has been completely emptied. We have, of course, been looking at the discharge cycle in very slow motion. In real time, the complete cycle takes only 1/10 of a second from start to finish.